Welcome back, ladies and gentlemen. We're looking at 2.6 day 1 rational functions. We're going to be graphing these rational functions by hand. Alright, and if you think of the word rational, of course, the word rational, first 5 letters is ratio, and ratio is just a fancy way to say fraction. So basically any function in the form f of x equals n of x over d of x, although we are going to make one other stipulation that n of x and d of x are both polynomials. So that's kind of important consideration, otherwise we could have a function that is itself another rational function and have fractions on top of fractions, and it gets all kind of crazy. So we're going to keep it kind of nice and have just polynomials in both of those places there. Okay, to graph these guys by hand, we're going to have to find any vertical asymptotes, and we'll talk about how to do that. Horizontals, again, we'll talk about that. We're going to find zeros. We've done stuff like that before. We're going to plot points between the vertical asymptotes and the zeros, because that'll help us with the shape of the graph. And then once we've got all those points plotted and all those asymptotes drawn in, we can draw a smooth curve or curves to get the graph. Some of these are going to be broken into bits and pieces, so it's going to get a little interesting. Well, let's get started. Alright, let's start our journey into graphing these things by hand by first talking about vertical asymptotes. Okay, now any x value that's, well, I'm going to get off of the words that I typed first. Vertical asymptotes are actually going to come from basically undefined values. And so basically any x value that makes us undefined basically is going to make us have my denominator function equal to 0. And if that happens, I'm going to get a vertical asymptote. One exception here, if it does not also make the numerator equal to 0. That's going to be a special case that we'll actually talk about tomorrow, so let's just kind of put that on the back burner for now and go from there. Alright, so if I've got some function like this, and I'm talking about any vertical asymptotes that I might have, really, again, I care about the denominator being equal to 0. So really, I'm just going to kind of pull the denominator out and treat it like it's its own problem. So I've got x squared minus 16, and I want that to be equal to 0. I trust it wouldn't take you too long to get to x equals plus or minus 4 there. Although I'll admit, since I'm talking about a vertical asymptote, what I'm talking about is a vertical boundary line, and I don't want to treat lines like that. That just seems unfair to them. They are their own people, so I think it's a lot better for them here to say x equals 4 and then x equals negative 4, listing them separately. I don't know, maybe that's just my opinion, but that's what we're going to go with. Alright, anyway, vertical asymptotes are also bad, and I kind of hinted this at a little bit, but they're basically also bad domain values. Okay, so if I'm undefined, that's something that doesn't work with a domain. So for the above example, we can say the domain is all reals. Okay, and of course, if you're a big fan of the all real symbol, feel free to use that in place of the phrase all reals. Alright, but then of course, except for negative 4. Alright, so we can give some kind of domain pretty much the second we figure out whatever the vertical asymptotes will be. Alright, so moving on from vertical asymptotes, we find ourselves looking at horizontal asymptotes. Alright, so again, asymptotes being boundary lines, and these are going to depend on the degrees the horizontal asymptotes are. This will come into play as we do some examples a little bit better than what I'm going to say now, but please just bear with me and we'll get to them when we get to them. Alright, so we're going to suppose that n of x is degree n, so just basically using a lowercase to correspond to that, and same thing, my denominator's polynomial is going to be degree d, whatever. So if the numerator is smaller than the denominator, basically is what this is saying, the horizontal asymptote is going to be simply the equation y equals 0. Alright, and if the numerator and denominator are equal, the horizontal asymptote is going to be the equation y equals, now brace yourself, notice the big blank. What we're going to do is we're going to take the lead coefficient of the numerator, and then we're going to divide that by big shock based on the numerator there, the lead coefficient of the denominator. Alright, and again, we'll get to that in an example in just a minute. Just let's get through this here. And then third scenario, if n is greater than d, so the numerator's got a higher degree than the denominator, basically there is no horizontal asymptote. Or maybe there's just no ha, so I guess that means there's no laughing. Alright, so let's take a few examples of the old horizontal asymptote rules here, so we can put them into play and make some decisions about this. And if you'd like to play along, you can of course graph these on your calculator as we're doing this, and maybe you can see how these things play out a little bit. Okay, but anyway, our first example here, I've got my function, and again, I'm just looking at the degree of the top versus the degree of the bottom. So if I've got degree 2 here and degree 1 here, well, again, the degree on the top is bigger than the degree on the bottom, so basically here I've got no horizontal asymptote. Alright. Okay, moving on here to the second one, I can see now that the degree on the top is now smaller than the degree on the bottom. Okay, since that's the case, by our set of rules, and again, feel free to graph that, I've got y equals 0 as my horizontal asymptote. Alright, third guy, hey, these guys match. Got a degree 1, degree 1. And, okay, again, now what that means, this is kind of the weird one. You've got to do y equals the ratio of the lead coefficients. Okay, now again, the lead coefficient is the coefficient of the highest power of x that you have. So in this case, I've got a 3 and a 5. So, well, 3 on the top, 5 on the bottom, 3/5. Groovy. Alright, last one. I've got the same powers again, x squared, but notice I've got now a 6 and a 2, and I know some of you guys are just hating reducing, but y equals 6 halves, and if you give me that as the final answer, of course, I will not be thrilled. I would, of course, want you to reduce that if possible. In this case, it's y equals 3. Okay, little note on the bottom here. Horizontal asymptotes, of course, they're boundary lines, but they do only deal with the extreme left and right ends of the graph. And so we might have graphs that cross the horizontal asymptote kind of in the middle. And what I mean by that is around the zeros and the vertical asymptotes. But the extreme left and right edges is where they really come into play. So, like I said though, we'll get to that as we get to it. Moving along. Okay, another important consideration when we're thinking about graphing these guys is zeros, and that's probably no big shock. We've talked about zeros of a lot of different things. Alright, now the zeros of our standard rational function here are basically, well, if you think of a fraction in general, if the top of the fraction is 0, who cares what the bottom is in most cases? So basically the zeros of this thing are the zeros of the numerator. And again, just like I said earlier, that we had a special case where I talked about the denominator versus the numerator. We had that sort of special condition here as well. So they're going to be a 0 if they're zeros at the top, as long as they're not also zeros at the denominator. Again, that's a special case we'll get into tomorrow. Alright, so here again, if I'm just talking about the zeros for this particular function, again, it's just I'm going to rip off just the top in this case. Okay, if I'm talking vertical asymptotes, I look at the bottom. Zeros, I look at the top. So 2x squared minus x minus 6, again, I'm just kind of thinking that as its own thing equal to 0. And then again, we can go ahead and factor that guy. Now, of course, failing factoring, I could always use the quadratic formula or something like that, but when I've got the chance to factor, that's what I'll usually use here. So if I use a 3 and a 2, and a negative sign here and a positive sign here, makes things work out very nicely for us. So the zeros of this graph are x equals negative 3 halves and positive 2. There you go. So simplest solvent polynomial equation, which we've done plenty of. Alrighty, so let's try to put the whole thing together and see how it plays out. Okay, so we're going to be graphing this function right here, x plus 1 over x squared minus 2x minus 15. Okay, and I've got kind of listed here a bunch of things that we can figure out to help us. Alright, so, okay, my vertical asymptote, again, vertical asymptote, that's going to come from undefined or bad domain values. And so again, I'm going to take a look at this guy, and hopefully I can squeeze this in here. But since he's a quadratic, I got to think about maybe factoring this guy. And he factors into x plus 3, x minus 5. Okay, so again, thinking about what makes that equal to 0, I have a vertical asymptote at x equals negative 3, and then a vertical asymptote at x equals 5. Alright, so I can basically two things at this point. I can say the domain is all reals except negative 3 and 5, and I can also translate that onto the graph. So I've got negative 3 as a vertical asymptote, so that means x equals negative 3, gives me this nice vertical line. And at the same time, I've got positive 5 doing that as well. And what a lucky break that was. Alright, landing right on 5 with my random dot. Alright, so there's a bit of framework, if you will. Okay, now some horizontal asymptote action here. Okay, and again, horizontal asymptotes are based off of our lead coefficients. Basically, the degree first, lead coefficient second. But anyway, my degree on the top is a 1, my degree on the bottom is 2. So what that, of course, means is that I've got a asymptote of y equals 0. And so, whoops, I'll pretend that goes right along the x-axis. So all the little world of make-believe, we can all see it, I'm sure. Alright, and then we got to go with some zeros. Okay, and again, the zeros are just setting the numerator equal to 0. In this case, I have a fairly simple numerator, so x plus 1 setting that equal to 0 gives gives me x equals -1, which again, remember what that really effectively is the same thing in this case at least as an x-intercept. So I've got -1, 0 as an x-intercept, so again that lets me put a dot here. Now notice that I do have a dot of our graph, of our point on our graph, which is actually on the horizontal asymptote, again stressing nothing I said earlier about how the horizontal asymptote is a boundary line for the extreme left and right edges, and not so much in the middle, because obviously our graph here is going to at least touch it, if not cross it. Alright, and from now, we've got this -3, we've got the -1, and we've got the +5 as, you know, good values for us to use as framework. But I need some other points to help me figure out the basic shape of this thing. So I'm going to pick, basically here's an asymptote, I want to pick a point over here in the left half of the graph, or the extreme left side of the graph. So something left of -3, I'll just use -5. Okay, and then I have this little sliver right here between the -3 and the -1, so pretty much, because I don't want to choose a decimal, I'll choose -2. And then again, I have from -1 all the way to 5. I've got a pretty big stretch here, and because I'm lazy, I'm going to pick 0 as my value to use there. And then after that, I have to go to the right of 5, and I think I'm going to pick a 7 for that. Alright, I could have picked any other values in there. You know, I could have picked instead of -5, I could have picked -6, -8, etc. Whatever, same thing in here, I could have picked instead of 0, 1, 2, 3. You get the idea. Okay, hopefully you can trust me on this, but as I plug in the -5 and I work this mess out, this works out to be a 1/5. Okay, as I plug in the -2, now, and just for the sake of argument here, if I do -2 plus 1, I get a -1 right there, right over here. And then if I plug in a -2 here, I get a 4. Plug in -2 here, I get another 4, so I've got 8. 8 minus 15 is going to be a -7, and so that gives me a 1/7. Okay, again, I said I was lazy choosing 0, because if you plug in 0, it just kills up all your x's, and you're left with whatever coefficients, or constants rather, that you have left. So in this case, 1 and -15, so that's -1/15. So I always choose 0 if it's an option. And then plug in the 7 by the same thing. Hopefully you can trust me, but after we crunch all the numbers there, that works out to be 2/5. Alright, so now we can just basically plot out these points. The -5, that's 3, 4, 5, now +1/5, just right there. Okay, -2 gives me a +1/7, so I'm sitting about right there. Alright, 0, -1/15, so just barely below. And then the 7, 2/5, so out here to 7, and then 2/5 is not very high, but there it is. Okay, now you may be looking at that and be going, well, that doesn't do much for me, and well, maybe you're right, but if we think logically for a minute, okay, here's a point on my graph. I've got this horizontal asymptote, which again, now I'm looking at the extreme left edge, so I'm not going to cross it. Alright, so pretty much it's an asymptote, it's a boundary line that I approach, so as I go to the left here, this guy's going to start hugging that asymptote, and just kind of take off to the left. Again, it won't cross it, because it doesn't cross asymptotes on the extreme left edge, so there it is. Okay, going here, I have a choice of kind of going up or down. Well, if I'm heading down, that means I'm going to have to cross, and I would make a 0 again, and I don't have any other zeros there, so I can't cross by going down, so that means I pretty much have to go up, and so this guy is going to have to head up and hug this asymptote. Alright, I've got these 3 dots together, which is kind of nice. I can just kind of connect the dots there with those. And then again, same thing that's happening here, is I have a choice of either taking off up or taking off down, and if I were to head down, I would have to make another 0, and I don't have another 0, so I don't have the option of heading down, so I have to kind of head up. So there we go in there. Same thing here. Okay, I'm going to come this way, and I can either head up or go down, and since I can't make another 0, I have no choice but to head in this basic direction there. Alright, and then similar argument that happened on the left can happen here on the right. This guy's going to hug the asymptote as he goes to the right, and then again, because I can't create yet another 0, I have no choice but to go up and hug this vertical asymptote that way. So there's that graph. Hopefully it made a little bit of sense to you. Alright, let's just do one more, just so you have another example of the whole thing in action. This one I made a little bit messier. Alright, but let's run through all this stuff again and see how it takes us. Okay, again, vertical asymptotes, I'm thinking of bad domain values. This one, no real factoring required, I hope. Hopefully you can get to x equals 2 and x equals -2 without too much effort there. Okay, our domain again, we can simply say all reals except 2 or -2. Here, if you said plus or minus 2, I wouldn't mind it so much, but again, since these are equations of lines, I do want you to keep them separate. Here, we're just listing two numbers, so you can count that as a plus or minus, and I'd be okay with it. Okay, but again, negative 2 gives me a nice asymptote this way, and positive 2 gives me an asymptote that way. Okay, they won't always have two asymptotes, just the two examples I chose did. Alright, so don't make that assumption, please. Okay, horizontal asymptote, again, I'm looking at my degrees, and this time they match. So then I look at my lead coefficients, and I've got a 3 and a 1. Well, 3 over 1, I'm pretty sure that reduces just to 3. So my horizontal asymptote now is y equals 3. So go up to 3 in the y, and then throw down... Wow, I can't make a horizontal line to save my life. Alright, but pretend that's horizontal through 3. Alright, and now we got some zeros we got to figure out. Okay, now this is a fairly messy numerator, so again, probably want to go out trying to factor that guy. Again, technically you could use the quadratic formula, but if I'm going to make you graph one of these by hand, I'm not going to make you do the quadratic formula at any point, so it should be factorable. Whether or not you recognize it is another story, but hopefully you do. Okay, so the 3 and the 7 will make me a 21, but I'm trying to make a 20. So I put a plus on the 7, a minus on the 1, and all the signs work out the way they should. So my zeros are x equal to 1/3 and negative 7. Again, now I can transfer onto the graph. 2, 3, 4, 5, 6, 7 is my nice 0, and then I've got that 1/3, which I'll admit is a little on the icky side, but there you go. Okay, so not too much work in there, but again, now looking at how I've got my graph chopped up, I've got this 0 here, and I want another point to the left just to make sure I know what it's doing. So I'll pick negative 8. Alright, and then I need to pick something between negative 7 and negative 2 there, so maybe I'll just pick negative 5. Alright, again, now between the negative 2 and this 1/3, I've got 0 as an option, so again, I'll guarantee I pick that every time. Alright, moving on from there, after the 1/3, before the 2, I think I'm going to pick 1. And then kind of further to the right, 5 seems like a pretty decent number, except the fact that my pen doesn't like to draw them. Okay, and again, if you can just kind of bear with me on this, if I pick a negative 8, I get a decimal that's about 0.4. Okay, plug in a negative 5 gives me something pretty close to negative 1.5. 0 again, just for the sake of, hey, look at this, 0, I get a negative 7 over negative 4, and that's actually 1.75. Okay, plugging in the 1 gives me negative 5.3. And then plugging in the 5, believe it or not, it actually works out to be a clean 8. Okay, that is going to be a rare occurrence that you get a nice whole number like that, but hey, let's just go with it. Okay, so the negative 8 gives me a 0.4, so there's negative 7, that's negative 8, and 0.4 is just shy of half. Okay, negative 5, so there was negative 2, 3, 4, 5, gives me a negative 1.5, so 1.5 is about there-ish. Okay, 0 gives me a 1.75, so that's positive. Almost a 2. Alright, the 1 gives me a negative 5.3, so 1, 2, 3, 4, 5, and a smidge. And then finally the 5 gives me 8. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, and again, it looks like just a bunch of scattered dots, but if we kind of think our way through it, we can actually get this. Okay, hopefully this one plays out fairly well. Again, I've got a horizontal asymptote up here, I've got a vertical asymptote right here, and I've got these 3 dots. So hopefully it makes a little bit of sense that this guy will be doing something like this, hugging the asymptote this way, and then heading that way to start hugging the asymptote there. Again, I can't curve back up because I would have made another 0 there. And I didn't, so I can't. Okay, again over here. Alright, got this guy kind of, here's a 0 and he's heading up. And again, I can't turn and go back down because I would have made a 0, so this guy's got to head up this way and hug the asymptote this way. Same basic idea. I'm heading down to this, and I got to keep heading down because, again, there's no 0 in this range. Alright, so this over here, got this dot up here, and basically what's happening here is the same thing that's happening down in the lower left. I've got this guy, he's got to kind of come this way and go up, because if he'd have headed down, he'd eventually made an asymptote. Same deal over here, he's just going to kind of head this way, and you know, I don't have a whole lot of room to get too close to it, but as the asymptote goes out, this graph will get close to it. So again, there's a reasonable version of that graph done by hand, and it didn't take any more than the last 15 years of your life. Alright, so there you go. Alrighty, so there's the assignment. Alright, 5, 9, 11, they're just asking you for some bits of information. 13 through 16 is a matching section, and then basically, so I'm just asking you to do 4 of those guys by hand. So hopefully this is something we can manage within the class period without too much effort. See you in class.